Hello everyone, welcome to Behind the Curtains. Let's explore and learn today a simple device that you are looking on the screen named multimeter. As the name suggests, it can do multi-purpose work. But in layman's term, if you can see on the screen, there are various things written and it is highly confusing. So let's understand clockwise manner, what does it mean? The first thing you can see the symbol written is V, and that's a straight line just above V, means it can measure DC voltage ranging from 2 volt to 600 volt, and various ranges available: 2 volt, 20 volt, 200 volt and 600 volt. Let's go below. That's a Greek symbol ohm given over here. That means it can measure resistance, and it has also range 200 ohm. 2k means 2 into 10 to the power 3 ohm. 200k 2 mega ohm, 20 mega ohm. Now let's go further. You can see that there's a symbol. It's a diode symbol given, which is used to check the continuity of PN junction diode. Next, it's written HFE, which is used to detect the transistor. Then that's a symbol A, and just above A, that's a straight line, means this it can measure DC current, and it has a range starting from 2 milliampere to 10 ampere. And in between the ranges are 2 milliampere, 20 milliampere, 200 milliampere, and then the 10 ampere. Let's go further. That's a symbol V, and above V, that's a sign which indicates AC voltage. So we have two ranges here to measure it, that is 200 volt and 600 volt. Now here it is written NCV, that is non-contact voltage. Also it can measure NCV, and what it is we can come later and understand. Let's go to the portions just below this multimeter. There are 3 sockets and it's color coded. You can see it's red, black and red. Try to understand this one first, then we will proceed further. Here in this socket it's written COM, means it's the common one. We have to attach the black connector to this socket. Then to the right of this we have V, ohm and milliampere written. So that means if we are going to measure the voltage, resistance and the current in the milliampere range, or this voltage, AC voltage also, we have to use this socket. And the next to the left, here it's especially written 10 ampere, means current range we have selected 10 ampere. This socket is going to be utilized. Let's connect the cord to this socket. So these are the cords. The black one will be connected to this COM. We are starting from clockwise direction, so let us choose this side first. I have connected it. So what we are going to do? Now we will switch on this multimeter and we will use physical devices, that means real devices, and we can check that whether it actually can measure these things or not. So I have a battery. It's a AA battery, and since we already know that it can measure up to 1.5, that's the maximum range. So let's take the pointer of this knob to select a range which is equals to 2 volt. Now check this. Okay, you can take out this portion so that we will have a better contact. Let's check and what we are getting. As you can see in the screen, it is showing us more or less 1.63 volt. That certain errors might be there, but it's okay. That is 1.63 volt. Similarly, if I'm going to use this one, this is exactly 1.559 volt. So this is actually measuring the voltage. Now let us go to the next function, that is the resistance it can measure. So if I'll take a carbon resistor, you can see this is the carbon resistor. I can measure this one. I don't know the resistance of it, so let's select it to 2K first. You can calculate, of course. No, it's not showing us. So let's go down. No, that means it is greater than 2K. So let's change the range to 200K. Now you can see. So if you don't know, also you can vary the range and find out what's the reading. That is 0.5 mega ohm, or you can say see here 0.6, and that's the last digit is varying, but anyways it's up the range of 0.6 mega ohm. Similarly, suppose you don't have this carbon resistor, so what we can do? We could be having a normal wire. I am using a safety pin over here. You can also find out the resistance of this wire. Okay, so let's take a small range for this one. No, we have to go further small range. You can see here this is 0.1 ohm. This is very small. Okay, because the length is also small. Or let's take a wire. You can also calculate what is the resistance of this wire. So let us try to connect. It is coming out as 1.60 or 1.61 mega ohm. So what are the other things we can do? All of us know that graphite is a conductor. So let's see that by using a pencil, that whether it is showing us a resistance or not. If it is going to show us a resistance, means it's a conductor. So I am using the two test cords at the lead. So let's go down with the small range. You can see here this is 0.018 kilo ohm, so we can go further down so that it's more or less 16.6, or you can say 17, around 17 ohm, which is the least resistance, indicates that it's a conductor. If it would have been showing us a very large resistance, then it would have been an insulator. But now it has a finite resistance which is very small, so it's a conductor. If we'll go and check the wood resistance just above it, you can see it doesn't going to show us any reading. In any of the range we have selected, starting from the lower range to the higher range, because wood is an insulator, I have already selected mega ohm, and still it is not showing us any reading. So that means it's a insulator, because it is showing us a very high resistance which is not measurable. Now let us go to a PN junction diode. and we have to choose the selection of this symbol. So first of all, we can check the continuity here. Now you can see in this direction the current is flowing, so it is showing us the reading in the digital display. But if I'll reverse it, it is not going to show us any reading, which indicates that in this direction current cannot flow. So it's actually showing us forward biasing and reverse biasing conditions. This is reverse bias and this one is forward biased. In this mode also we can check the continuity of the circuit. Now suppose we have a wire, just we want to check the current is flowing in it or not. If we'll connect it, it will give you a beep sound, which indicates that the circuit is functioning. Now if we'll take another PN junction that is known as LED, here also you can determine if it is forward biased or if it is reverse biased. Take the legs and connect it to the test cords. Now you see in this direction it is functioning. It's very slowly glowing, but it's not visible, I think so, but still you can see the display of this multimeter which is showing us a reading. Means this side it is allowing the current to pass through, means forward biased. And if I'll interchange my sides, it's not showing us any reading, means it is reverse biased. Now coming to the HFE mode. In HFE mode, if I'll go to HFE, this is a transistor I am having. What does this HFE mode gives us? It gives us the idea about the current gain. Now suppose I will insert this one here, emitter base collector. It's not showing us any reading. Let's go to base collector emitter. You can see here it's showing us a reading. So we can determine the current gain by using this one. So let's go to the next function. That's the current, DC current it can measure. So let's go to the highest value first. Now let us connect. I've already taken a battery attached with the LED. Now you see on the screen that's showing a current in the circuit that is around 95 milliampere, but it's showing a negative sign, means I have just attached my terminal in the opposite direction. Doesn't matter, I can change it. You can see it's around, right now it's showing 100. It's 90 to 100 milliampere. Let's go to the further function, that is your AC voltage. Let's choose a selection of 600 volt. I have a household supply of around 220 volt. Means I have to select the range which is higher than 200, so 600 volt that is available here. Since this is AC, we have to take maximum precautions. So first of all, let's attach this two test cords inside the socket and don't switch on the switch fast. Release your hand, take maximum precautions, then switch it on. It's showing AC. You can see it's measuring 246 volt. Let's just switch it off. Now coming to NCV. Here in this video we have measured the voltage by contact method, and also without multimeter, we can do it the way the layman's use, that is called voltage tester, by using a tester. So instead of using a tester, how to do it? That is your non-contact voltage. Without direct contact between the socket and the device, also it can measure the continuity by giving you a beeping sound. Yes, the circuit is functioning. So let's go and check it. Let me first select my range is NCV. I'll just switch it on. Now you can see it's showing us H means high voltage. There is also a range called low voltage that is not showing us right now. You can see here it's showing low L. Now if we'll go closer, it is going to show us H means high. So these are the functions available with us while we are using a multimeter. I hope so this small video has enlightened you in knowing what are the functions of a multimeter. Thank you for watching. Stay tuned for the next videos.